Hello, everyone. I hope you all are doing well. So, those who are watching me live, can you guys confirm to me? Am I clearly audible or not to all? So that we can start our today's agenda. So, I hope you all are aware. Today's agenda is to talk about the interview based questions that are very frequently asked in a lot of companies, right? So we will try to solve it out and let's see how many questions we will be able to solve in today's session. I really want to talk about four questions mainly. One question I want to give you as an practice problem, you can say, and three questions I'll try to speak about and I'll try to do the implementation as well. So that you will get to know that, okay, how basically the understanding will be there, how basically we will be able to solve any kind of interview problems whenever they will come into picture whenever we are going for an interview. Okay, so before that, please give me the confirmation that whether my voice is clearly audible to all and whether I am properly visible to everyone or not. Then maybe I will start the session within few minutes so that everyone will join, whosoever is watching me live. Right? Is my voice is clear? Clearly audible to everyone? Can I get some confirmation from you all? In the meanwhile, people are joining. Uh, will you code in Java? Doesn't matter. Maybe in Java I can do or in Python. I'm not sure as of now, but the main perspective here is to understand the logic. Please don't go with the programming language here. If you are here, try to have that mindset that I will try to understand the concept. Okay, I will invest my time and I will try to understand the concept rather than focusing on that which programming language I will use to implement the code, because that is the last step which I will do. Before that, I will talk about the approaches, I will talk about how we can solve that problem, right? And what are the things that we have to take care of whenever some interview question will come into picture. Okay. Yes, audible. Perfect. Perfect. Thank you for the confirmation. Many people have given me the confirmation that it's clearly audible. So I believe my voice is loud and clear. Uh, Now, what I will do is, meanwhile, other people are joining, I will try to share my screen with everyone so that you let me know whether my screen is also properly visible or not. Is my both screen, the coding screen as well as the scribbling file where I used to write the content and I used to explain to you, does these two screens are visible to everyone? Akshat is saying, in DSA, if we just see the pattern and prepare them, is it enough? By saying pattern, what does that mean? See, you have to understand that what are the approaches that we have to solve a given problem. If you will, and one more thing is, don't focus on the quantity of problems. That's what I always say to all the students. Don't focus in DSA that how many problems I have solved in Leetcode, and that number of problems solved is not giving you the guarantee that you will be able to crack any XYZ company. Always try to solve the problem in a quality manner. What is the meaning of a quality here? You should know that what are the approaches that we have to solve that problem, what is the time and the space complexity required to solve that problem, and can I think of any other approach? Always try to find out the new approaches. And if suppose in today's session also you feel like that there is some approach which I was not aware about before joining the session, and now I get to know that, okay, this approach also exists, try to write it down somewhere, because as a human brain we forget. Even I also forget. So I always have a habit to be with me my diary, my pen, so that whatever new thing I came across, I used to write it down, right? So have something with you so that whatever new things you feel like that you are not already aware of, make a note, and please after the session make a thorough conceptual understanding of that point. Okay. Okay. So shall we start now? What's the time? It's already 6:05. I think we can start. I have already waited for 5 minutes. So now the very first question which I want to talk about is the square root of x. How many of you are aware about something called as binary search, which is one of the very important topic, I would say, in the DSA complete module? Binary search, one of the very amazing searching algorithm whose time complexity is big of log of n. How many of you are aware about that? Can you tell me? So if you will observe on my channel itself, you will be able to see the complete DSA understanding in a playlist by the name of DSA using Python. If there is someone today who is saying that I am not sure about the concept, I would suggest please go inside this playlist and check it out. Here you will find out whatever algorithms I am talking about today. Okay, can you see the binary search video is there? So this is the topic which is very very important in DSA. Recursion, another topic which is very much important. So there are few topics in DSA which I feel everyone should be aware of, and binary search, recursion are one of them. Okay. So today's topic, today's question, which is the very first question, is square root of x. It will be using the concept of binary search. So first of all, let me try to give you a brief overview of what binary search is all about. And then maybe we will move towards the problem statement again and we will try to solve it out. So, uh, what is binary search? Can anyone tell me? And why it is called as binary? Just a brief overview I will give because I don't want to spend much time over the concepts part today. The major focus is to talk about the problem statement and their solution in terms of the interview problems. If you want to get into deeper understanding of any concept, as I already shown you, go with that playlist. You will be able to get a complete in-depth idea about the algorithm. So when I'm talking about binary search, as the name suggests, it's a searching algorithm. But this searching algorithm we usually apply on a sorted array. On a sorted array. And there is a reason behind that. When the array is sorted, at that point of time only you can apply a binary search. And there is a reason behind that. What's the reason? The simple reason is that in that scenario only you will be able to figure it out that whether you have to move towards the left side of an array or the right side of an array. So suppose I will provide you one simple array here which is in a sorted fashion. For example, you will be having 2, then you will be having 6, 8, 12, 16, 25, 30, 37. This is a sorted array that I have. Okay, this is a sorted array that I have. 0, 1, 2, 3, 4, 5, 6 and 7. So if you can see here, I will be having 8 number of elements. And suppose I really want to search 25. Let's say I want to search 25. This is the element which I really want to search for. What I will do here? What I will do? In binary search, the very first thing that we have to figure it out is the value of mid. What is mid? It is the middle index of this array. So here if you will see, my lower index value is 0 and my higher index value is something which is equals to 7. I hope everyone can see this. Lower index value is 0, higher index value is 7. So if I'll say what is mid here, it is nothing but is equals to low plus high minus low divided by 2, which you can also set as low plus high by 2. But usually I prefer the first formula, this first one, to be much better as comparable to the second one. Even though both will give you the same answer, just to avoid the overflow thing, I would suggest that always go for the first way to calculate the mid value. Now, if I'll ask you, what is the mid value here in the first scenario? It will be, let's say, for the simple calculation, as of now, I'm taking 0 plus 7 by 2. So let's take the lower bound of that, which will be equals to 3. So can I say that my mid value is something which is equals to 3? Can I say everyone? My mid value is something which is equals to 3. I am taking a lower bound. Lower bound meaning if you will say 0 plus 7, 7 by 2. So 7 by 2 is 3.5. Take the lower value, 3.5. Before decimal, the value will be 3. So what is the value of error of 3? What is the value of error of 3? It's 12. It's 12. Now, there will be three important conditions that you have to understand here. The first condition is this binary search says, first of all, you will do the same task until or unless your value of low is less than equals to high. What you have to do? Calculate the value of mid like the way we have done, low plus high minus low by 2. And after that, first condition is, if suppose at any point of time your error of mid value is equal to the value of x is a searching element that you're looking for, in that case though you can directly return the value of mid, right? In that case though you can directly return the value of mid. If that is not the scenario, what can be the another scenario? So here I'm writing a pseudo code, please don't go with the syntax, right? If error of mid is less than x, now think over it. This is the scenario which I believe we are in. What is our value of x? It's 25. What is the value of error of mid? It's 12, right? So if you will observe here, can I say the value of 12 is less than 25? Can I say everyone? Please stay tuned until the end of this session. You will be able to get an amazing insights from this session, believe me. Okay, so please try to focus 100% with whatsoever period of time we are in this particular session. At the end of the session, believe me, you will be able to get a very beautiful insights on the problems which we are solving it today, right? That will really help you in cracking the interviews. So if you will observe here, 12 is less than 25. Now tell me, in which direction should I go? Left side of mid or right side of mid? That's why I have taken a sorted array. That's the real reason. Now I can analyze that because my value of error of mid, which was 12, is somehow smaller than the value of x. So can I say that I have to move towards the right side of the array? Right side of mid? Can I say the only search space which I have is now this only? Can I say everyone? Is it correct? Can I say, can I able to reduce the search space into the right side? That's it. So what I will do is, how will I move towards the right side? I will update my low value with mid plus 1. Can I say everyone? Can I say? If that is not the case can be vice versa. Maybe the value of error of mid is bigger than x. In that case, what will you do? If the value of error of mid, for example, here you are not searching for 25, suppose you're searching for 6. Then can I say that my value will be present at the left side of mid? Can I say everyone? My value will be present at the left side of mid. It means at that point of time, I will update my high variable with mid minus 1. Is this clear? That's the only thing which binary search says to us. So what it is doing is, it is dividing my search space into two halves, two halves, two halves, two halves until I reach to a searching value which I really want to calculate. Now here if you will observe, let's take as of now the value of x as 25, which was there in the original case. So now what will happen? This is the condition number 1. This is the condition number 2. And this is the condition number 3. Can anyone tell me in what condition we are lying here? Condition number 1, 2 or 3? I think it is 2, right? It means we have to update our low value to mid plus 1 because now we are exploring towards the right side of mid. It means my low value will become, can I say it will become 4 now? My high value will be, can I say it will be equal to maybe 7? And now my mid value will become low. As of now, low plus high by 2. 7 plus 4 is 11. 11 by 2 is, can I say it will be 5? So what will happen? If you will observe, now I am pointing to the error of mid, which is equal to the value of x I am looking for. So what I will return? My answer will become what? 5. So I will be able to get the index of that element which I am looking for. This is how the complete binary search works. This is the real implication of binary search that I have talked about in my playlist as well. By the name of a binary search video, you can see, check it out. But I have given you the context, how it is working. Considering this thing in your head, we want to solve now this question. Square root of x. Question is very simple, but the thing is that we will try to solve it via the binary search approach. What they are saying, you have been given a non-negative integer. You need to return the square root of x rounded down to the nearest integer. Okay? You must not use any built-in exponent function. Always remember, whenever you are solving any mathematical question on Leetcode, even in coding platforms, even in interviews, don't use any built-in function. If suppose someone is saying calculate square root and directly you are using math.sqrt function, it's a wrong way to approach that question. Interviewer wants to check your logic, so apply your logic. Don't use any built-in function there. Okay? Now, what they are saying, for example, the value of x is 4. The answer will be equal to 2, because everyone knows here the square root of 4 is simply 2. If suppose the value of x is 8, this is important point here to understand. If suppose the value of x is 8, at that point of time you have to return the nearest possible number, means lower bound of that number. Means if you will observe, the square root of this is 8 is not a perfect square number. So the square root will be 2.82842, something like that. So you have to take a lower bound, minimum value, which will be 2. So the answer will become 2 here. Is this clear to everyone? The answer will become 2 here. So the question is how I will approach this question. Any idea? The problem statement is very simple. In the square root of x function, if you will observe, the problem statement is very simple. What they are saying is, they are saying we will provide you the value of x. Suppose the value of x is equals to 16. Suppose the value of x is equals to 16. What I am looking for as an answer, the result should be equal to 4. How will I approach this? Any idea? Anyone who can tell me? How can we approach to this problem? Simple ways that we will keep on doing the multiplication until we reach to this value of x, right? But I'm looking for how we can solve this problem via the binary search approach, because that's somewhere we will be able to get the optimized solution. That's why I have explained above binary search first, and then I'm coming to this question. So Akshat is saying that we will do val is equals to mid into mid and check with simple binary search approach. Even Som Wansi is also saying the same thing. That's true, right? Now the question which came to some students' head is that, okay, this is fine, but what is the range? How will I get to know what is the low value and what is the high value? Think over it. Very simple. Think over it. What I'm saying here. Here in the above scenario, we will be having the value of low. We will be having the value of high. In this case, how will you get to know what is the value of low and what is the value of high? Suppose the value of x is 16. Now, very simple mathematical property I'm talking about here. Any numbers, square root value, can I say, will be always less than or equal to its number by 2? Can I say, everyone? What I'm saying here, the square root number of 16 will always be either equal to 8 or less than 8. Can I say? Yes or no? So can I take the high index value as x by 2? Because I am pretty sure someone said that take the value of high as x. I can take. But then you are increasing your search space. That's the key point here. Instead of taking the value of x, can we take x by 2? Take any number in your head. Any number which you can think of, not 16. Any number. Tell me that this number is having a square root bigger than x by 2. You will not be able to find out. So is my hypothesis, is my assumption is correct or not? This mathematical assumption, it's correct, right? Okay, one more thing. When the value of x is 0 and when the value of x is 1, what is the value of its square root? If the value of x is 0 and if the value of x is 1, What is the value of the square root? Can I say it will be 0 in this case and 1 in this case? Meaning, what I am saying here, that if the value of x is less than 2, can I make this statement that return as it is x? Can I make this statement? If the value of x is less than 2 meaning, because we are dealing with non-negative integers, they already have mentioned non-negative integer means either we will be having a value as 0 or we will be having a value as 1. In that case, can I say that the number will be as it is x itself? So I will return x directly. Is it correct? Does everyone agrees with me? It means what I'm saying here, can I start my low value with 2 and high value with x by 2, in this case 16 by 2, which is equals to 8? So what will happen here? Now try to understand. We are starting with the low value 2, then 3, then 4, 5, 6, 7, and 8. Now, what is the value of mid? Mid will be equals to, this is low and this is high. This is low and this is high. What is the value of mid? It will be 8 plus 2, 10 by 2, which is 5. Now, what we can do? Our actual number is equal to mid into mid. Can I say, everyone? This is what you guys are saying to me. So can I say that the number which I will be able to get is 5 into 5, which is equals to 25? Now, because this 25 number is less than x, then what should I do? Whether should I move towards the left side of mid or right side of mid? Now see how that approach of binary search I'm applying here. What I'm saying is the number is 25. So my value of x was 16. So shall I move towards the left side of mid or right side of mid? What will be your answer? Because the number is smaller than x, in that scenario, what should I do? If the number is bigger than x, in that scenario, what should I do? Can anyone tell me? In our case, my number is 25, which is bigger than x. So let's take this first. What should I do? Should I move towards left side or the right side? Left side. So what we can do to move towards the left side? So you are saying to me, just move towards the left side. That's correct answer. So what should I do to move towards the left side of an array? Which variable should I update? Anyone who can tell me? Which variable should I update here? Anyone who can tell me? Can I say it will be high, which is equals to mid minus 1? Think it logically. Whatever things I am doing here, don't cram anything. Does we have to find out close to square root if number is found? If number is not found, yes, we will do that. Just wait for a moment, Akshat. We will do that. We will handle that scenario as well. But as of now, let's take a scenario of a perfect square number. Okay, then we will try to handle that non-perfect square number as well. Let's take it step by step. Now, if there is a opposite scenario, in that case, can I say that we have to move towards the right side of an array? It means our low value will become mid plus 1. Our low value will become mid plus 1. Can I say, everyone? Does this make sense to you? This is fine? Okay. If there is an exact match, if that number and the value of x is almost equal to each other, in that case, what we can do? What we can return? We can return directly that mid value. Can I say, everyone? Can I say? So what will happen in this example? We will be having 5. So I have to move towards the left side of this 5. It means in the second iteration, my low value will become 2 and my high value will become 4. So again, we will check what is the value of mid. It will be 4 plus 2 is 6, by 2 is 3. So we will be able to get the answer as 3, which is a mid value. Now again, the number will become 3 into 3, which is equals to 9, right? Now this number is smaller than the value of x, Obviously, I have to move towards the right side. By saying I have to move towards the right side, I need to update the value of low as mid plus 1. I hope everyone now agrees with me. So now my value will become 3. Low value will become 3. My high value will become 4. Does everyone agrees with me? Is this point is clear to everyone? What I am doing here? My number is 9, right? 3 into 3. Now, this value of 9 is less than the value of x because my x is 16. So what we have to do? We have to move towards the right side of an array. Means what we have to do? We have to move towards the right side of an array. So my low value will now point to the 3 value. So what I will do now? Now I will try to find out a new mid value. So new mid value will become again 4 plus 3 is 7 by 2, which is equals to 3 itself. Again, my mid is equals to 3. So what will happen? Again, my number is 9, which is less than x. So again, I will move towards the number which is less than x. So I will move towards the right side. Again, I will update my value of low, which will become 4. My value of high is again 4. So what is the value of mid? It will be 4 plus 4. 8 by 2, 4. Now, this is a situation where we will be able to get the number as 4 into 4, 16, which is exactly equal to the value of x, and we will directly return the value of mid. So our answer will come out to be 4 in this case. This is how we will be able to get the answer of a perfect square number, right? Is this fine? Is this complete flow is fine to everyone? Shall we move ahead? Is this complete flow is fine to everyone? Shall we move ahead? Yes or no? Can you guys confirm to me, is this fine or not? Simple? Interesting? So far, so good? Now, one thing which we have to focus as of now, if so far, so good. One thing is, if the number is not a perfect square number, for example, if we will be having x value as 8, then what we will do? In that case, what we will return? Now we have to think on that part. That's the only thing which is pending. If the number is not a perfect square number, in the above example, value of x was 16. So we will be able to get the answer as 4. But now the situation is that if the number is not a perfect square number, we will do the same step. But now we have to think what we should return. Either I will return the value of left or the value of low, or I should return the value of high in that scenario. Just focus on it. There is nothing to cram here. Focus here. You will be able to get it what we should return. Okay. Start the process again. What is the value of low? It will be 2. What is the value of high? Same step I am doing, which is 8 by 2, which is equals to 4. So what will happen? We will be having a value of low as 2. Then we will be having 3. We will be having 4. Now, what is the value of mid? Mid will become 4 plus 2 is 6. 6 by 2 is 3. It means our mid value is this in the first scenario. Now, this is number is equal to mid into it, which is equals to 9. This 9 is somehow bigger than the value of 8, which is x, right? Then where should I go? Should I move towards left side or the right side? If the number is bigger than the value of x, should I move towards the left side or the right side? Who will tell me? In this case, the number which is mid into mid is bigger than the value of x, then shall we move towards the left side of an array or the right side of an array? Left side, it means my low value will become as it is, which is 2, but my high value will become mid minus 1. What is the value of a mid? 3. 3 minus 1 is 2, right? Now, again, what I will do? I will calculate what is the value of a mid. It will be 2 plus 2 divided by 2, which will be equals to 2. Which will be equals to 2. Does everyone agrees with me? Now, what is the number? Number is 2 into 2. Number is 2 into 2, which is 4. this number, this number, can I say this number is smaller than the value of x? In this case, shall I move towards left or right? When the number is smaller than the value of x, because the x value is 8, shall I move towards left side or the right side? Any answer? Left side or right side? My number currently is smaller than the value of x. So shall I move towards the left side or the right side? Very good. So you guys are saying that just explore towards the right side, as Kunal, Pritish, many students have said. Okay, fine. It means you guys are saying that the low value will become mid plus 1. So it will be 3 and the right value will become 2, right? So what is the value of mid here? Okay, now there is a case. This is the scenario where we should stop, because what I told you, in the binary search, we will apply one condition. We will apply one condition that the value of low should be either less than or equal to the value of right. This is the while condition that we are applying, and in that step only we are applying that binary search approach, right? Here this condition is failed now. So we will not find out here the value of mid. That's where I will go out of the loop. That's where I get to know that I don't have this perfect square number. Now, what is the answer we need to return? We need to return the lower bound. This is the lower bound or this is the lower bound? For the 8 part, what is the output we want to get? 2. Now check, is this 2 is available in low variable or the high variable? Here this is high or this is right, whatever you will say. Any variable you can think of, low or high. It will be available in high. So what I will do, when I will exit out of the while loop, I will return the value of high. Is this fine to everyone? Is this fine to everyone? This is what we will do in the code as well. So don't ask me when I will write the code that why you are returning high or the right, anything you can say, or the right? Any variable you can say. Is this fine to everyone? Is this fine now? If suppose interviewer will ask you that I want to return the upper bound of a value. Suppose the answer is 2.832. So I want upper bound means I want 3 as an answer. If the answer is 3.245, I want upper bound means 4 as an answer. Then what will you return? You will return the value as, can I say, low? If interviewer will change the problem and will say that I want to return an upper bound of that particular solution, then you have to accordingly change the logic. Don't cram it that I told you that you have to return the high value, then you will return only the high value. Just keep your focus on the logic part. Why I am saying so, why I am doing so, this why part is very important to understand. Is this clear to everyone? Is this clear to everyone? Shall we move ahead to do the implementation now with respect to whatever things we have understood so far? Shall we try the implementation now? If everyone agrees with me? Yes or no? Can we use one pointer also to store the value? There is no need actually. I will show you how we can do the implementation just now. Okay. So you will get to know the better idea what I am saying here. Okay. Let's do the implementation. Okay. What I will do here, let's take few variables. Let's define few variables. What we are doing here, we will say, first of all, what is the base case condition I have talked about? What is the base case condition? What is the base case condition I have talked about while explaining? Anyone who can tell me? If the value of, what is the base case condition? Can I say if the value of x is less than 2, in that case, what you will do? What you will do? If the value of x is less than 2, return the value as x. Perfect. Done. If that is not a scenario, then what I will do? We will take a number. So we will take it long type number. Why I am taking the long type, I will let you know. Then we will take a mid value. We will define a left or you can say low pointer, which will be equal to 2. We will define a high pointer, which will be equal to x by 2. Or you can also define it like left and right. Whatever you feel it comfortable to you, you can define it like that. So we have defined the left index, we have defined the right index, and we have defined the range as well. Now, what is the condition of applying a binary search? So now what I am doing is I am applying a binary search algorithm. I am applying a binary search algorithm. Now what I will do, I'll try to apply the condition first while the value of left is less than equal to the value of right. What I want to do, first of all, calculate the value of mid. It will be left plus, I am using this formula. I already have explained why I am using so. Now, the number, what is the number value? It is mid into mid. Can I say, everyone? It is mid into mid. Just now we have done in the PDF as well. Now, this mid value is of integer type, right? What I will do is, this num is long type. What I will do is, I will typecast this integer value which I will get in the long form. How we can do a typecasting? Just apply long here. So what you will be able to get as an answer is a long type answer. Why I'm doing so? Because it might be the case that when you do the multiplication, your number value will be very high, which your integer will not able to store. That's why we are taking an NUM variable as of long type. That's the only reason. Is this fine for everyone? Now we will check the conditions. If this number is bigger than x, then where should I traverse? Left or right? If the number, which is the multiplication of the mid value, is bigger than the value of x, which you are looking for, shall we move towards left side of an array or right side of an array? Who will tell me? Left side of an array or right side of an array? Left side, right? Traverse towards left side of an array. So what I will do here, I will say right is equal to mid minus 1. That's how we usually traverse, right? Condition number 1 is this. What is condition number 2? Else if, let's suppose my number is less than x. Then where should we traverse? Left side or the right side? Can I say that's a vice versa case where we need to traverse towards right side of an array? Can I say, everyone? It means the value of the left is equal to mid plus 1. Can we say? Else, what we can do? We can simply return the value of mid, because the else meaning is that there is a match. There is a match between the number and the x value that we have. If suppose you will come out of this while loop, but still there is no match. You come out of this while loop, still there is no match. Then what we can do? If there is no match, then what we need to return? Anyone who can tell me? Left or right? There is no match. It simply indicates that we are trying to handle this case where the value of x is equals to 8. Then what we will do? Anyone who can let me know? Very good. We need to return the answer as right. Just now we have seen, right? Just now we have explored this thing. Perfect. Shall we try to run this? Let's run this. Okay, it's accepted. The two cases are accepted. But until or unless you will not submit it, don't consider that your code is fine. So let me submit it first. So it is passing all the test cases. Now it is fine. Ask me if you have any sort of doubt. Now, does it dependent on any programming language? If I will say to you that do the code in C++ or in Python or in any other programming language, if you know this logic, it's very easy for everyone to do it in any programming language you want. Is this correct or not? This is how, see, no one will ask you in an interview direct question of binary search. No one will say that, okay, just implement binary search. No one will say that. What they will try to use to you is they will check your knowledge. They will say that, okay, does this person know binary search application? How we can apply that binary search in other code? That's what they want to see to you. How you store left as 2? Because if you will observe, when the value of x is less than 2, means either it is 0 or 1, we have already handled that case. We have already handled that case. That's why I started with the value as 2. That's the reason. Why we return right at the end, ma'am? Because just now I have shown you our value, when the value of x is equals to 8, where it is stored? It is stored at the high index. Because when the number is not a perfect square number, just like the example we have done, when the value of x is equals to 8, we want to return the lower bound of that number. If the number is 2.8, the square, see the test case number 2, when the value of x is equals to 8, the answer is 2.822. है ना? What we want is, we want to return the lower bound, which is 2. Now I have shown you that this 2 is stored in the high index, in the right variable. That's why we have returned the answer as right. This will come when you will get exit out of that while loop. Now if I'll ask you, what is the time complexity of this approach? If I will ask you, what is the time complexity of this approach, who will tell me? Can I say anyhow I have applied here binary search only? Just a bit of change I have done on the basis of the question that I have. This is a base case condition, which is a constant answer. After that, I have just applied a binary search. That's it, right? So can I say, we all know that the time complexity of a binary search is big O of log of n, right? If I will ask you, what is the space complexity of this approach? What is the space complexity of this approach? Can you say? It will be constant, right? Why? Because I am not using any extra space here to implement this code. I am not using any extra space. Is this perfectly clear? Shall we move ahead to the next question now? It's already been 42 minutes. Let's try to solve one more problem, and then maybe I'll try to come up again in the live. If you are enjoying it a lot, if you will like this video, share this video with everyone, make this reach, then I will again used to come here on this platform and will try to teach you live. Shall we move ahead to the next question? Can you solve minimum ASCII delete sum for 2 strings of Leetcode? Definitely yes, we will try to do it, but obviously we can't do it in one go. Otherwise the sessions will be too long, and the students who will watch in the recorded mode, they will not get the motivation if the video length is very, very high. So I usually try to keep it at least within 1 hour. That's my real intention is. So sometimes if we will not able to fulfill our target, we will try to do it more live. Okay. Let's move ahead now with the next question. So this is the question. I am sharing the link with you, everyone. Just read it out. Okay. What this problem is saying? This problem is saying that we will provide you the arrays containing n distinct numbers. Listen the problem statement very carefully. What they are saying? We are providing you an array of nums containing n distinct numbers in the range 0 to n. Okay? Return the only number in the range that is missing from the array. If you will observe here, there will always be one number which is missing in that specific range. If you will observe here, we will be having 3 numbers starting from 0 is there, 1 is there, and 3 is there. Which number is missing here? 2 is missing. Can I say? 2 is the number which is missing here. Similarly, here if you will observe, we will be having 2 numbers. 0 is there, 1 is there, but 2 is missing. So I will be able to get the output as 2. Similarly, here if you will observe, I will be having here 9 numbers, 0 to n. 0 is there, 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there, right? 7 is there, but 8 is not there, right? The 9 is there. So what is the missing number here? It is 8. The question is, we have to find out that missing number. So one thing which you have to understand here is that what they are saying is, in this missing number problem, They will always give you one hint. If you will catch up that hint, it's very easy for you to solve the problems. In this missing number problem, if you will observe, they are saying that the range of the numbers in the array, the list, is from 0 to n. Always remember that. And they're saying there will be always one number which is missing. Now, many people, okay, let me just ask from you, how will you solve this problem? The very first basic brute force approach, which everyone can think of here, is that why not I will sort. So, this is the approach number one, which I think everyone will be able to tell to me. This is what I believe. You will say to me that, Priya, what we can do is we can sort the array first. Whatever array is given to us, we will sort that array. Now, once you will sort the array, you know, because it's in a range, right? It's in a range. So you know that the next number of that array is the plus one of the previous number. Can I say? The next number of an array is the addition of the previous number. Can I say? For example, in the test case, I will be able to get the sorted array like 0, 1, 2, 3, 4, 5, 6, 7, and then 9. Can I say? So when I sort that original array, I will be able to get this kind of array. This next number is the number of previous number plus 1. Similarly, here also 2 is 1 plus 1, 3 is 2 plus 1, 4 is 3 plus 1, 5 is 4 plus 1, 6 is 5 plus 1, 7 is 6 plus 1, 9 is not 7 plus 1. 9 is not 7 plus 1. Means that's where there is a fault. That's the fault area where we have to print that because 8 is not there, which is the previous number plus 1, we can return that answer. We can return that answer. So in this way, can I say that I will be able to get that missing number? Can I say that I will be able to get that missing number in an array? Can I say, everyone? Does everyone agrees with me? Very basic approach. I think anyone can tell me this approach by looking this question itself. But here if you will observe, sorting the array itself will take how much time complexity? Sorting the array itself will take how much time complexity? Anyone who can think of its time complexity part? I hope if you already have watched my playlist of DSA using Python, I already have talked about something called as merge sort. And when you're calling any function by default also by using that arrays.sort function, or you are doing it manually by applying a sort function, in worst case also it will take big O of n log n. So time complexity wise, it is quite tedious task. The question is, can we improve on this time complexity? Can we make it better? And the second approach, which a student has already talked about in the chat window, is something called as using that concept of Gauss formula, which we learned in our lower classes. That is, what we can do is, I have some range, I have some values, right, in the array that are 9. So if I'll just copy this. So I have this value, right? I have this value, right? 96423571. Here if you will observe, what I can do, I know that the values will be in the range from 0 to n, and there is one value which is missing. If I will be able to get the sum of that n natural numbers, what is that formula? What is the sum of n natural numbers? Can I able to calculate that by applying one formula itself, which is nothing but is equals to n into n plus 1 by 2? Can I say that is something which we have is the expected sum? Can I say that that is something which we have is the expected sum of an array? What is the actual sum of an array? The addition of all these numbers. The actual sum will be the addition of all these numbers. So here if you will observe, how many numbers we have here? The value of n is 8. But actually one number is missing here. It means what I will do is I will try to calculate the sum of 9 natural numbers. It will be 9 into 10 divided by 2, which will come out to be 45. What is the actual sum here? If you will try to calculate here, what is the actual sum? Can you check it out? It will be 37. It will be 37. So what will happen here? If I will say, what is the missing number here? What is the missing number? Can I say it is a subtraction between what is the expected sum minus what is the actual sum? Can I say, everyone? What is the expected sum minus the actual sum, which is 45 minus 37, which is equals to 8. Yes or no? Yes or no? Now, in this case, what will happen? This is something which you are doing in a constant time, right? You are just applying a formula to calculate the n natural numbers. This is something which you will do by applying one for loop, so it will be big O of n. Now what you will do? This n is the length of the formula, sorry, length of the array, Akshat. This n is the length of the array which we have. This is 8. Now, one number is missing, right? One number is missing. So, in total, how many number of elements we have in the array? It will be 9. Can I say? It will be 9. 8 is there, 1 is missing. So, we have to calculate the sum of 9 natural numbers. Can I say, everyone? Yes or no? Is this correct? So, this is how basically we can form up the idea. Is this correct or not? Is this correct or not? Any doubt in this approach? Please ask from me. Anyone, any doubt? Shall we move ahead towards the implementation of this thing? So what basically I have taught you here, I have shared with you that what we can do here is, first of all, we can calculate the expected sum. And the expected sum is equal to, what is the value of n? What is the value of n? It is equals to nums dot length. So what I am saying here is that the expected sum is nothing but is equals to n into n plus 1 divided by 2. And this calculation is a, can we say, constant task? Now the next thing which we have to calculate is the actual sum, which initially I have initialized with 0. Now what I can do, I will traverse my complete for loop for int number present in this nums. What I will do? I will say actual sum plus is equal to that number. Can I say, everyone? So once I will move out of this for loop, what I will return? I will return what is the expected sum that we are getting minus what is the actual sum that we are getting. And that will become my missing number. That will become my missing number. So if I just run this, accepted, submit this, it's submitted. Now here if you will observe, calculation of this expected sum is a constant task, because you are directly using the formula to calculate the sum of the n natural numbers, right? Calculation of this actual sum is a bigger task, where you are trying to traverse the complete for loop. That's why it will become big O of n. So if someone will ask you, what is the time complexity of this approach? So can you say it will be equals to big O of n? What is the space complexity of this approach? What is the space complexity of this approach? Can you say it will be constant only? Can you say it will be constant only? Because I am not using any kind of extra space apart from initializing the variables. That's it. Yes or no? Apart from this approach, there is another interesting approach that we have to solve the same question, which many people are not aware of. That is the approach number 3, which I want to talk about here, is via the XOR operation. Is via the XOR operation. How many of you knows how XOR operation will work? Anyone knows the truth table of XOR? So if suppose we will be having 0 0, 0 1, 1 0 and 1 1, what will be the output you will be able to get? When the values are same, XOR property says when the values are same, this is A and this is B. When the value of A and B are same, the answer will be 0. When the value of 1 and 1 is same, answer will be 0. But when you will be having different values, the answer will be equal to that value itself. Means if suppose you will be having A and you want to do the XOR operation, or let me write it like this. You want to do an XOR operation with that 0. The answer will be equal to, anyone can tell me? When I am doing any number XOR with 0, the answer will be, can I say it will be equals to A itself? If you will observe, 0 XOR with 1 is 1. 1 XOR with 0 is again 1. So always remember that any number XOR with 0 will always return you the answer as A only. That's the very crucial property of XOR operation. Can I say everyone? Okay, perfect. Now, how basically this property will help me to solve this problem? Let's try to understand. Let's take the same example. This is the example that we have, right? What is this? This is what we have as an original array, right? This is what we have as the original array. What I will do is, my missing element, I will try to create one missing element whose initialization we will do with the value of n that we have. What is n here? What is the total size of an array? It will be 8 plus 1 is missing, so it will be 9. So what I will do is, I will try to use this missing element value with 9, which is the length or size of my array. Okay. For example, here if you will observe, you will be provided in the range from 0 to n. So I am talking about this n. What is the highest limit? So here my n value is, highest value is 9. So this is 9. Now what we will do is, we will try to do a XOR operation. We will try to do the XOR operation of traversing that value of I equal to 0 to n. So what will happen? I will make one for loop. I will say move from 0 to n, and inside that I will do the XOR operation with I and nums of I which I have and that missing element which is 9. So this is whatever with the value I will be able to get here, that is the final return value, which is the missing value which we will be able to get. Or you can say that is the missing element that we will be able to get. Try to understand what I am saying here. It might be something which is new for everyone. So please be very much focused here. This is a bitwise operation. Bit manipulation is something which we have in DSA, which usually helps to do the task very much faster. So what will happen here? When the value of I is equals to 0, so what you will do? You will do 0 XOR with, what is the value of nums of 0? 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7 and 8. So what will happen? What will happen? You will say nums of 0 will be 9. Then you will move ahead. Again, 6 XOR with 1. 2 2 XOR with 4, 3 XOR with 2, then 4 XOR with 3, then 5 XOR with 5, then 7 XOR with 6, then 0 XOR with 7, then 1 XOR with 8, and XOR with 9, which was there previously. What is happening here? What will happen with this equation? Can you imagine? Whatever be the two values, similar values we have, the answer will become 0. 0 and 0 will return the answer as 0. 9 and 9 will return the answer as 0. 6 and 6 will return the answer as 0. 1 and 1 will return the answer as 0. 4 and 4 will return the answer as 0. 2 and 2 will return the answer as 0. 3 and 3 will return the answer as 0. 5 and 5 will return the answer as 0. 7 and 7 will return the answer as 0. Only one element is pending, which is 8. Now, what is the value of 0 XOR 8? What is the value of 0 XOR 8? All the values which are similar combined together make an XOR operation and will form a value of 0. Only 8 will left because 8 is not having the partner of 8 to make it 0. Just now I have talked about 0 XOR with capital A is capital A. So 0 XOR with 8 is equal to 8, which is the actual missing element that we have in the array. Can I say, everyone? This is something which is a very unique approach, and by understanding this concept or the beauty of XOR operation, you can apply the similar approach in other questions as well. So I just want to make you guys aware that how XOR operation works. So what I'm saying here is very simple thing. If I'll just refresh this particular thing and we'll try to do it again. So what I have done is I will take one variable called as missing element, whose value I will initialize with the length of my array, which I have. What I will do is I'll try to use one for loop. I less than nums dot length I plus plus. And what I'm doing here is I'm doing very simple task. I'm saying missing element, do an XOR, which is equal to I XOR nums of I. Once this task will be done, I am pretty sure that what it will return as an answer is the missing element only. So if I just run this, okay, there is some mistake which we are doing here. There is, I believe this is how in Java we used to apply an XOR operation. Okay, now it is fine. So there is a syntax problem. These two be equal, attached with each other, XOR and equal to. What is the meaning of that? Missing element is equals to missing element XOR I XOR nums of I. So if I'll just submit this, now it is working fine. So basically what we have done here, we have just applied on an XOR operation with all the elements that we have. Now here if you will observe, with respect to the time and the space complexity, everything will remain same. But this is something which will work much faster. Why? Because here we are using a bit manipulation, right? So here if you will observe, the time complexity of this approach is again big O of n, and the space complexity is something which is equals to big O of 1. Right? So can we use hash map? How will you do via hash map? Tell me the approach also. Maybe you can use that, but I believe that when you will use the hash map, it will take some extra space, right? You will create a map there. Here we are doing it without taking any extra space. That's why it is more efficient as comparable to the hash map, even if you will take that approach. Okay, is this fine for everyone? Is this two questions are fine for everyone? The first question that we have talked about today is square root of x. The second question that we have talked about is finding out a missing element. Now, for you all, there is one question which I want to give, because there is no benefit of just teaching you all and you will not even practice. I always say that these things will come from practice. Even though you will learn from 10 different mentors, from top notch mentors, until or unless you will not spend your own time on these things, until or unless you will not use your own brain to utilize those concepts, everything is in vain. Even though you have spent your 1 hour, but after the session, if you will not spend your half an hour to 45 minutes to practice it out, then this complete 1 hour will be in vain, even though you will understand so many things from this session. So this is your today's problem, and I really want everyone to answer me in the comment section of this video. Maybe what you can do is you can upload your code with its time and the space complexity part on in your GitHub profile, and after that, what you can do is you can attach that GitHub link in the comment section of this video. I will for sure see your code and will reply to you that whether that approach is correct or not, or either we can optimize it in a more better way or not. I just want to look it out what things you have learned from this session. So finding of peak element requires a good knowledge of binary search, which I already have teach in this session. Now I'm giving you this link. Even if you will go to the Leetcode and search peak element, you will be able to get this problem. But still, I'm giving you the link of this problem. Even though I will attach this problem link in the comment section of this video. Okay, with the resources which I have done in today's session, I will attach all the resources, even the notes, the code file of square root of x, the code file of missing number part, and the question link which I have given you. If you will understand this question, what they are saying, I am explaining you the problem statement, but I will not tell you the solution here, so that you will be able to get a clarity about the problem statement, and then you can think of the solution part. See, what is they're saying? A peak element is something which is bigger than its neighbors. For example, if you will observe here, let me open my Epic Pen. So what they are saying here, they are saying, if you will observe, for example, this is 0, 1, 2, and 3. Here, if you will observe, this 3 is bigger than 2, right? As well as 1. What is the neighbor of 3? Neighbor is 2 on the left side and 1 on the right side. 3 is bigger than 2 and 1. So what is the position of 3? It is 2. That's why the output is 2. So here, if you will see, 3 is a peak element and your function should return the index number as 2. Similarly, here you will observe, here if you will observe, 5, no, not 5, it will be 6, right? 6 is somewhere bigger than both 5 and 4. So 0, 1, 2, 3, 4, 5, and 6. So the index number which they're returning is 5. So you have to understand the literal meaning of the peak element. The peak element is the element which is bigger than its neighbors. That's the real meaning you have to understand from this part. And you have to find out the index of that peak element. For example, you got the peak element as 3 or the 6. What is the position of that? That is something which you have to return. Now, always remember that they will always give you the hint as well. The hint is you must write an algorithm that runs in log of n time. Now you should know what is the algorithm which is giving me a logarithmic of n time. Even I don't need to tell you what is the approach that you should think of to get a appropriate result. This is your today's, I would say, in a nutshell, assignment which you should do after this session, so that you will be able to get a good hands-on on the concepts that we have learned so far in today's session. I believe you find it insightful, and if you really want me to take more sessions live with respect to these concepts, you can also write me down in the comment section, and I will try to come up more frequently and will try to interact with you all with respect to this particular part as well. Okay. With this, let's end today's live. I hope you find today's live insightful. Please do share this videos with everyone, whosoever is looking for this kind of knowledge, and do subscribe to my channel. It would really help me to reach to more students, more people. And bye bye everyone. Take care. Happy learning to all.